Hello, it all started off when I saw this tweet yesterday and I decided I was going to try to analyze the photo to see what I could get out of it. After a very brief amount of looking at it, I could tell that it was done not in 1 month, but in 6 months, because it starts with a new moon, waxes all the way to a full moon, and then wanes back to a new moon. And we know that the new moon is in the same part of the sky as the sun is. So the sun would have had to been here or very close to it, and the moon would have had to be in a similar location. So let's just take a look at the movement of the moon. So that's where the moon is, and in the course of 24 hours, the moon was here 24 hours ago, and 24 hours later, it went around like this and ended here, which means that right about now, the moon is drifting across the sky at around 14.4 degrees per hour. And after 24 hours, it's not quite back into the same longitude as it was 24 hours previously. If I jump ahead 28 days, we can see that it's over here. If I go ahead 29 days, it's over here. So in the course of a month, it's gone from here to here. I was trying to figure out how to fit this, and I just wanted to visually see where the moon would have been in the sky every day for a full month. And I decided therefore to implement something similar for the moon that I have implemented for the sun. I've already shown this in some of my other videos, but this cyan line represents the path of the sun or the object that you're watching for a 24-hour period. And I've also added the ecliptic, which represents where that object was, or in the case of the sun, where the sun was in the celestial sphere for the last year. I've also added the analemma mode, which shows where the sun is in the sky for the same time of day throughout the year. So just to give you an idea, I'm going to go ahead for the next 2 years. If I just start in the normal ecliptic mode, you'll see that as I go throughout several years, you can see how the sun moves in a 24-hour period and or throughout the year like this. And of course the analemma mode is very similar. So that's what I had implemented for the sun, and I wanted to see what the moon did as well. So I implemented something very similar, and if I'm interested in the moon, you can see that that's where the moon is now, and all of these go back in time. That's where the moon would be today. That's where it would have been yesterday at the same time. This is where it would have been 2 days ago, same time, and so on and so forth, until it wrapped around, and that's where the moon was a month ago. So as we can see, in the course of 1 month, new moon to new moon, it's in the same general area of the sky. And I decided to take a look at the analemma mode as well for the moon. And as you can see, it looks quite interesting. It kind of looks like a teardrop at this point. This is where the moon would be based on the moon's sidereal day. And I'll cover that in just a little bit. But I set out to try to analyze what this photo tried to capture, and as best as I can tell, and I may be wrong on this, this was meant to represent how the moon looks when overlaid over the sun's analemma. And from what I can tell, one or more of these may have been post-processed, or possibly, in the case of the new moons, multiple exposures were done and possibly edited to overlay the contrast of the dark part with just a hint of the direct reflection of sunlight off of the moon. And this one is definitely brighter than this one. So if this was just captured past the new moon phase, it's always possible that the sun had just gone below the horizon and the moon was just following it, being able to just capture enough contrast to get this one. And then if this one is also real, this one is probably closer to the sun than this one. Although I would not rule out the possibility that these are composites from other phases of the moon, just to show where the moon would have been on a new moon. It would seem to me all of the other ones, however, are in fact probably single images taken without any kind of special processing. I'd also probably hazard a guess that this photo was done by taking probably hundreds, maybe even thousands of pictures over the course of the duration and choosing the appropriate image to get that solar analemma shape. And I may be wrong on this too, but it seems like possibly some of these are taken on the same day maybe. So if it is meant to represent where the moon would have been on a solar analemma, it brings up a few interesting points, such as where was this photograph taken? And I wanted to try to analyze this as well. And if this was the case, and the analemma was shaped like this, it would suggest to me that this was taken looking towards the west. As you can see, the smaller loop of the figure 8 is towards the right, similar to this one. So my guess is this was taken looking towards the west at around the sunset, or the moon set in this case. And then the next trick would have been to try to determine if this was what latitude this might have been taken in. And from a quick eyeball guess, it would have put the analemma pointing up at about a 10-degree angle. If I fiddle around with my location, I would probably, without knowing any other information, suggest the possibility that it might have been taken at a latitude of 22 degrees or thereabouts. But even that poses a few problems, because even at this latitude, you can see that if the moon follows this curve here, it's still descending and then it comes back up like this. Whereas over here, it's actually going up. This could also give it a little bit more credibility that it is somewhere maybe in the southern hemisphere looking west. And the images around the full moon might have been taken not quite at the right time, so it would have followed some kind of pattern like this. So at that point, I was making a few guesses, and I really didn't feel comfortable whether or not those guesses were correct. I decided to go online and find out if I could go and get more information on Georgia Hoffer, and it wasn't very long before I found her website. And sure enough, the first image on there was the image that I was looking at. So by clicking on that, I went and I found out where you can go and get all sorts of her artwork. And the second one looked very interesting, which was the canvas print showing the lunar analemma. So just like the sun that shows where the moon is every day, not for a year in this case, but for a month, I also added a mode that shows where the moon is based on that 14.4 degrees per hour rotation, showing the lunar analemma. And sure enough, my calculations showed that lunar analemma creates a teardrop that looks similar to, but not quite the same, as the one in this print. So the next thing that I tried to do was try to figure out where this might have been taken. I was looking at the loop and where the pinch in the teardrop was. So here's a better look at it. Here the pinch is towards the left and is below the rest of it. If I were to look at it today, it appears that it is lower than and more towards the right if I was facing west. This is what it looks like if I'm facing east. And again, at this point, here I am, I'm looking at the latitude in the southern hemisphere. By that point, I did a little bit of investigation, not much, it was right there, and it turns out that most of her photographs, if not all, are taken in the Dolomites, and this one was taken in the Cridola group in Italy. So at that point, I kind of figured that this had to be done in the northern hemisphere, not the southern hemisphere. So now if I take a look at how it should look in the northern hemisphere, and I can probably switch over to Italy. As of today, the teardrop is above rather than below when facing east, and it's above and to the right when facing west. So then I started to question whether I had implemented everything properly or not, because it doesn't quite match the photos. I tried looking at how it would appear throughout the year like this. And over the course of many months, that pinch still appeared to be above and to the right. I'm pretty sure that I had the location correct at this point. I was in fact told where. But as I started to play around with this, I noticed that the pinched side of the teardrop was starting to open up again into what looked like a figure eight as I was going back throughout the months like this. And then I got thinking maybe this one is correct, and I need to find out what year this might have been taken. So after a little bit of trial and error and going back months and months at a time, I put this photo somewhere around June, possibly July of 2019. In fact, I could probably even try to figure it out. Over in 2018, it doesn't quite look right. This is September 2019. Here it's already starting to look a little bit off. So here, this looks promising. 993. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So, as best as I can tell, after looking at different dates and different times, if that is a new moon right about there, which would represent this one month earlier would have been September, would have been August 28th or thereabouts of 2019. If I had to give a time and or date as to when this series of photographs that were made to make this print, I would say it was from August to September of 2019. If you like this video, I would appreciate the thumbs up, the subscribe, comment below, all that other good stuff. That's going to be it for now. Thank you for watching, and I'm going to see you again in another video soon enough. So bye for now.